go through right triangle trig is that I set it up just a little bit differently. Whenever you're looking at right triangle stuff, what do you know about every right triangle?
90-degree angle.
There's a 90-degree angle.
And then
Now, in the right triangle, whenever you're talking about it, you've got a right angle, you've got two other angles, doesn't matter what they are. The one part of every single right triangle that never changes is the hypotenuse. Do you agree?
yeah,
The hypotenuse is always going to be located where?
across the right.
Across the right angle. Okay. So your hypotenuse will always be located across from the right angle. That never changes. Okay. What changes up a lot of times is when you're dealing with what angle. Now, last year in geometry, you guys just called it angle X or whatever. What we do in algebra 2 is we call it theta. It's just another name for an angle. Theta.
Yeah, well,
Just circle
it's a circle with a line.
That's all it is. It's just kind of a circle and it just kind of brings it through. I think the official symbol of it is kind of an oval with a line like that. Draw it however you want, doesn't matter. So we're just going to call it theta. And when you're dealing with trigonometry, remember, if you guys remember this, trigonometry is nothing more than about perspective. So whatever, depending upon what angle you're at, that tells you which one's your opposite, which one's your adjacent. If I'm here at this angle, what is that side? The opposite. Therefore, this is the adjacent. Now, if I was up here, I would have to switch them around. Remember, the trig is all dependent upon perspective. So if we look at just a regular old boring right triangle, we're talking about right triangle trig. Shut the lights because of the glare. When we're talking about this, we can label out the three trig functions: sines, cosines, tangents. Good old-fashioned SOHCAHTOA. You never heard about SOHCAHTOA?
There's another one that's a lot easier. And adjacent.
So if you're talking about the sine of theta, the cosine of theta, and the tangent of theta. The sine is the ratios of what two sides?
The opposite to the
Opposite hypotenuse. Good. Cosine. Adjacent.
adjacent to that.
And then lastly,
So that's the
opposite over adjacent. And if I'm not pushing it too much here, I'm assuming you guys have all used those abbreviations like that before, right? Yeah, it's pretty standardized. Now, what I am going to do here is I'm going to introduce you guys to the inverses of these trig functions. There are inverses of these trig functions: cosecant, secant, and cotangent. You probably did, but just so you guys remember what they are. You have, each of these trig functions has its own inverse. Remember, inverse is basically flip the fraction. So the inverse of sine would be cosecant. The inverse of cosine is secant. And the inverse of tangent would be cotangent. And basically, when we're talking about the inverse of these, all we're doing is if sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. Secant would be hypotenuse over adjacent. And then lastly, it's your adjacent over opposite. To be honest with you, more often than not, you'll probably, when you're solving right triangles using trigonometry, you're usually going to use the normal ones because that's what the buttons on your calculator do. But just remember, sometimes they might give you the secant is blank over blank. That means you just have to remember what parts it goes into for the triangle. That's all it is. Okay. Did Seth show you guys that last year? Cosecant, secant, cotangent? Okay. I figured you guys probably had seen it. I wasn't sure if you remembered it. That's all. Okay? Questions? Like I said, a lot of this is going to be straight review, so we have these. 30, 60, 90, 45, 45, 90. Again, these are also your special right triangles. If I have a 45, 45, 90, you guys remember the pattern for the sides? Something, something. Root 2? Okay. So your 45, 45, 90, oops, was x, x, and x root 2. Vaguely remember that? And if you have 30, 60, 90,
Wouldn't it be x? X2, x3, x2.
good. So the 30 was the x. The 60 was what?
The
The root, yeah, good.
And then the other
Now, what they do a little bit differently now is that these guys, these special right triangles is what's going to help us develop the unit circle. Now, I know you've already seen that, that's exactly where it comes from. The unit circle is built off of special right triangles, and that'll be, we got a couple of days before we get to that part here. But what I want you guys to see here is that I want you to start to understand and to remember what the trig functions are for the special right triangles. If we know that the sine of 45 degrees is going to be root 2 over 2, right off the top of our heads, it's going to make your lives so much easier as we get through this chapter and into chapter 14. Okay? Things like that. So what I want to do here real fast is kind of set up two of these triangles. For the values of x, I'm going to use 1. Okay? So that means my sides are 1, 1, and root 2 for a 45, 45, 90. My sides for the 30, 60, 90 would be 1, root 3, and 2. So what I want to do here is use those pairings to go through the trig functions of setting them up so we know what their trig values are. All right, just for short review. So 45, 45, 90. If I say it's 1, 1, and root 2. If I want to start out with that saying the sine of 45, the cosine of 45, and the tangent of 45. Oh, quick question. Do we ever worry about finding the sine, cosine, tangent, or any trig function of a 90-degree angle?
No.
And why not?
Because it doesn't exist, or it doesn't exist, but
Just doesn't matter.
it's like
Okay, well think about this. If I wanted to figure out what the,
there would be no parent. There would be no other parent.
well yeah, let's say, what's the tangent of 90? Do you know what the opposite and adjacent is when you're at a 90? You know what the opposite is because it's across from you, but which one would be considered the adjacent? See what I'm saying? It doesn't work. So that's why we don't worry about finding trig functions of 90-degree angles. It doesn't clean. So again, sine of 45 is opposite over hypotenuse. 1 over root 2. Remember rationalizing? Remember the shortcut. It's root 2 over 2. Remember, when you rationalize, what you're doing, in essence, is multiplying by root 2 over root 2. So it's root 2 over 2. Okay. Cosine is going to be what?
Sine over root
1 over root 2, which is? And then tangent. 1. The reason it's tangent is 1 is because it's opposite over adjacent. They're both equal to 1. 1 divided by 1 is? Okay. Now let's look at the 30, 60. Again, if I'm talking 30, 60, 90, 1, root 3, and 2. We need the sine of 30, cosine of 30, tangent of 30, sine of 60, cosine of 60, and the tangent of 60. And when we work with the specials, again, these are ones that'll pop up more often than not. If I want to find the sine of 30 degrees, that means it's going to be my opposite over hypotenuse. Well, if I'm at 30 degrees, my opposite is 1. So the sine of 30 becomes 1/2. Again, trigonometry is all about perspective. If I'm at the 30-degree angle, what is my adjacent side? Root 3. So my cosine would be root 3 over
2.
Good. And then lastly, the tangent. Tangent is what over what?
Opposite over adjacent.
Opposite over adjacent. So in this case, it would be 1 over root 3, which is? Very good. Okay. Now we switch perspective. Switch perspective now, we go to the bless you, the 60-degree angle. Now my opposite is root 3. So the sine of 60 is root 3 over 2. Good. Thank you, sir. Cosine of 60 gets 1/2. And then lastly, the tangent. Root 3. Yeah, it's just root 3 then. Okay. Not so bad? Gotta stop selling that. It's more popular. Okay. Now, lots of crap. Again, sine was what? 1/2? Cosine was of 30?
It was 3 over 3.
Root 3 over 2.
Root 3
over 3. Now, real fast, I want to show you the inverses. If I'm looking at 30-degree angles, and I know the sine was 1/2, the cosine was root 3 over 2, the tangent was root 3 over 3, what would the cosecant be? 2. You just flip it. It becomes 2. The secant would be 2. Very good. 2 root 3 over 3. And then lastly, this one, when you flip it, you get 3 over root 3. So it becomes root 3. Yeah, because what happens, you get 3 root 3 over 3, which is root 3. Okay. Not so bad. If I look at it, what was the 60s? 60s were root 3 over 2, and then I don't think I need to go through all this, do I? Remember, if it asks you to find the inverse, you just take the regular and flip it. Okay? I don't know, fill the chart then. But like you remember, if I'm going to use trig or specials, does it matter? Does it matter what you use to find side lengths? No? What would be the easiest way to find the side length? What? I'd use sine of 60, or better yet, it's a 60-degree angle, right? Isn't that a special right triangle? And I know opposite to what?
Then you know that 5 is
So I know this side has to equal to 2x, right?
5
What's x?
over 5.
So it's 5, so this becomes 5 root 3. What I'm doing here, guys, is reminding you, if you're using special right triangles, it's quicker. Could you use sine, cosine, whatever? Sure. But use sine. I know that the sine of 60 is x over 10. Which basically means when I have to solve for that, what do? Multiply by 10. So I multiply by 10. Well, sine of 60 was what? Do you remember?
Root 3 over 2.
Root 3 over 2. So you get 10 root 3 over 2, otherwise known as 5 root 3. I'll tell you one thing, guys, when you get into some of these problems, if it's a special, leave them in radical form. Okay, try to remember to leave them in radical form. Because your calculators don't. Well, you remember how to simplify radicals in these calculators, right? No, I remember. I thought I showed you guys. Remember, go to your. If you want to type in and figure out what the simplified radical form is of that, let's see. It was. If I'm doing 10. If I wanted to simplify out, what would that have gotten us? Yeah, divide whatever number is by x squared. So let's say it would go to y equals. Just so, for example, type in 12 over x squared. I know that's not the side length here, but let's say you had to simplify the square root of 12. You go to your table. As you're scrolling through your table and you're looking in the y column, what you're doing is you're looking for the smallest integer value that you get before it goes to all decimals that are less than 1. Okay? And so in that case, you'll notice how it's 2 and a 3. It's 2 root 3. It's a nice shortcut, especially for those of you guys that don't like to simplify your radicals, and you don't have to worry about having 2 calculators. The multi-use did all that for you. Just a little heads up. All right. Solving right triangles. This is something you guys did in geometry. Again, you'll be given either a side and an angle, maybe 2 sides, and you have to find all the missing parts. How many parts are in a right triangle? 6 of them, right? Which one of them you will always know? Therefore, how many parts do you have to solve for? 5. Good.
4. Because you're going to be given another one.
Well, yes, I see what you're saying. But you could be given, you might not be given. But what I'm saying here is, no matter what, there's 6 parts. You're always going to know one for certain is a 90-degree angle. Then it's a matter of just finding the rest of the parts. And it's kind of ironic. We were actually just doing this today in geometry. So here, if I'm setting this up, I know that I'm starting out here with a 20. I know that side little a is 12. What's going to be the easiest thing to solve for? B. And how do I solve for B right away? What do you get? 70. That was. These two have to be complementary. Okay. So now, again, the way I always like to set these things up with trigonometry is I always like to reuse my givens. The reason that I do that is because let's say I accidentally subtracted from 90 incorrectly and I got 60. Because I can't do math in my head. If I use that 60-degree angle, will anything else be correct in the triangle? No. Nope. But if I reuse the 20 that was given to me, I still run the risk of being correct later. Does that make sense? So if I'm starting here at the 20, again, what I always like to do is circle where I'm working at and try to see what I know. Well, this is a hypotenuse. That's an opposite. Therefore, that's an adjacent. If it doesn't come to you right away as far as where your parts are in the triangle itself, take a second, label it if you need to help you guys remember this, because I know it's been about a year since you looked at this. So if I'm going to solve for side C or side B, what are the 2 trig functions we're going to use with a 20-degree angle? Sine and tangent. So the sine of 20 would be 12 over C. We agree on that? And then the tangent of 20 would be 12 over B. Do you remember the trick when your variable was in the denominator? Yeah. Do you guys remember that? Whenever you have the unknown in the denominator, it's always going to be this. All you're doing is just changing those out. Every time. Every time. You just flip-flop.
You just enter the.
Yeah. So that tells you now, quick reminder, do you guys know how to check your mode if you're in degrees or radians? And this first section, this section, law of sines and law of cosines, I try to group them all together. That way everything's going to be in degrees. Hit the button on your calculator that says mode. And just make sure that it's highlighted under degree. If it's highlighted on radian, please change it. We're not dealing with radian measures. Radian measures are all in terms of pi, and that's when we get to the unit circlets like. Okay. Decimal places and stuff like that. Okay. So again, just make sure you're in degree mode, and now all you have to do is take 12 divided by the sine of 20. Then what do you get? Louder?
35.
35.1. And what do you get when you take the tangent? 12 divided by the tangent of 20? 33. Oh no?
Yeah, it was 32.96.
Oh, let's say it's 32.96. I like 2 decimal places.
It says 32.9697.
So then it'd be 32.97. Try to remember to solve, round them up to 2 decimal places. That's all. Okay? Not so scary? Vaguely remember this stuff? Okay. Take a second to do this one then. All right. So if I'm starting out with B at 15, that gives me, what is that? 75. Little b is 42. So the sine of 15 is 42 over c. The tangent of 15 is 42 over a. Whatever you got for your calculator is probably right. Yes, ma'am. All right. Let's see if you remember what this is then. Do you remember how to work with angles of elevation and depression? All right, Mommer, how do I work with them? Carefully. That's a good answer. Let's see what you remember here. Angles of elevation and depression basically stem from the following. When you have two parallel lines, right? If I'm looking up, this is my elevation. It's what I'm looking up from the horizontal going upward. Right? The depression is what angle pair relationship with it. They're the same. They are they're alternating interior. But what happens here is that angles of elevation and angles of depression are congruent. They're the same angle. So depending upon what they give you as far as a word problem might be concerned, so they might say the angle of elevation is such and such, the angle of depression is whatever. You might have to draw a diagram and reuse them within triangles. What happens quite often is that you're going to be given something like an airplane is at a specific height. The depression angle to the runway, you have to flip things around to figure out how long something is. It's not a horribly scary problem, but it's kind of it can get kind of weird. Let's see. I had an elevation problem here. Come on. Again, what happens here is you get a problem where it's going to give you a bunch of information, where you have an airplane flying at 12,000 meters. From the pilot to the angle of depression to the tower is 32 degrees. How far is the tower from the point directly beneath the plane? Again, what you're looking at here is they're saying the angle of depression is the same as the angle of elevation, which brings you inside a 32 here. 58, good. Do I need that?
What, 58?
Yeah. But you're fine if you had to solve the whole thing out. But if he just wants to know how far away something is, you're looking at this distance here. What trig function are you going to use to solve that? Tangent. Very good. No, you're not looking for the diagonal distance, you're looking at how far, yeah.
Wait, why is the tangent? Sorry.
Because I'm at the 32-degree angle, I know my opposite, and this is my adjacent. So it would just be tangent, left 32, 12,000, or something. Okay? You're going to find out a lot of times when you're dealing with angles of elevation and depression, you're probably going to use tangent. Now, did you guys used to do that clinometer thing last year? Remember with the upside-down protractor and the straw?
Oh,
Yeah.
gosh, darn it.
That's what you guys were doing with.
Did that last year?
No.
Okay, I was gonna say, 'cause I don't know which one.
Yeah. No, I didn't like your class, so I didn't do it.
Good.
Should give you 2 reasons why. Those first 2 guesses don't count. So, like I said, a lot of times angle of elevation and depression, it's a very common thing to be used with tangent. How's your Flappy Bird going?
That's a good question. It's freaking addictive. You should just punch me in the face.
I'm getting really good at it.
Okay, let's put it away though. Thank you. Because you can't notice at all what you're doing, just so you know.
Well, oh, I never thought I knew you knew what I.
I knew that you knew that I was playing Flappy Bird.
This isn't what we're doing. I got different stuff.
Oh.
Yay, so we're doing
Give you some problems now. Like I said, this first section is all review. Give you guys a little bit of time just to go ahead and ask questions, work on it at your own pace here. What I'm gonna have, let's see.
Squiggles. I love squiggles.
Let's do numbers 20 through 24
Even.
and 37 through 51.
Even.
Okay.
Oh.
Go ahead and get started on that now, guys. Like I said, I've updated the website to have new book pages are in there for you. Should be all good to go. This is all review, ladies and gentlemen. This is all review.
The whole chapter?
No, these first couple of sections, because you guys did law of sines and law of cosines last year, right?
Yeah.
Okay. So this will be review as well, the first couple of sections. I did get those tests. They're all done. They're all graded. I just have a couple people left over to get them. So if you wanted to check your scores, you know, that kind of stuff. There's a couple of problems that most people got wrong, and I'll go over that when we hand those back. Okay?
You shouldn't count those problems.
No, I should.